Hello everyone, I welcome you for yet another video on number system, and this will be the last topic on the number system. And topic today that we are going to discuss is LCM and HCF. Before understanding LCM and HCF, first we will decode what is the meaning of it through the terminology, and then basically we will go through the questions as well as some PYQ that is for you to solve at the end, right? All right. So first, understand LCM. It is also called as least common multiple. Right? So that means that what is the meaning of it? The first term that I want to have here is multiple, and then it should be common. Among the common multiple, it should be the smallest. The three things that we are going to understand. Right, now first, what is the meaning of multiple? Let's say if I have 2, what is the multiples of 2? Multiples of 2 is nothing but the multiplication table of 2. All those numbers which will be divisible by 2 are called its multiple. So that means that 2 will be divisible by 2. So 2 is the multiple of 2. Then 4, then 2 3s are 6, 8, 10, 12, so on. So if I want the multiple of 3, right, then it can be 3, then it is 6, 9, 12, 15, 18, so on. If I want multiple of, let's say, 9, then 9 2s are 18, then 27, 36, 45, 54, so on. Right? So you can see that, you keep on increasing the, multiplication table, you will be keep on having the multiples. So that means that for all the numbers that I have taken here, 2, 3, 9, first thing what I can observe is, the number itself is its multiple. So that means that if the multiple of 2, 2 is the multiple of 2, 3 is multiple of 3, 9 is multiple of 9. So that means that the least multiple of any given number is the number itself. Right? We are talking about the multiple in the sense that we are talking about the integral multiple. Right? So that will be 2, 3, 9. If I want to take 2 is the multiple, the least multiple of 2, 3 is the least multiple of 3, 9 is the least multiple of 8. So that means that the least multiple of any given number or the least integral multiple of any given number is the number itself. What is the largest, the multiple of a number? It will never end. You can keep on, making it 14, 16, 18, so up to infinity. So the largest multiple is infinity, but the least multiple or the least integral multiple of a given number will be the number itself. That is 1. Now if I have multiplication of 2 also, multiplication of 3 also, let's say if somebody asks what are the common multiple, what is the common multiple? It should be there in the multiplication table of 2 also, it should be there in the multiplication of 3 also. So that means that let's say if I take 6, right, so 6 is a common multiple, right. Next, if I look at 12, right, if I keep on increasing the 2 multiplication table, 14, 16, 18, so the next number which is common is 18, right. So that means that, we are getting multiples of 2 and 3. So that means that when you are talking about common multiple between 2 and 3, what I am saying, it should be divisible by 2 also, it should be divisible by 3 also. When in the last class we had discussed about it that, if a number is divisible by 2 as well as 3, let's say they are co-prime to each other, then it will also divisible by the product of those two numbers. That means that we are basically searching for the multiples of 6, right. So that is what the common multiples are. Within the given common multiple, we are searching for the least common multiple. Now if you look at 12, 18, 6, right. So among them, what is the least common multiple? That is 6. So that means that LCM of 2 and 3 is nothing but 6, right. So that is how you are going to find the least common multiple. Now let's say in our day-to-day life, right, so where do you see this application? Let's say, when you see the question also you'll understand it. Let's say a person is coming for every 2 days. That is, if I came today on Sunday, then he will come on Tuesday, then again he will come on Thursday, right, again Saturday, again after 2 days Monday, like that for every 2 days he is coming. Now there is another person who also has come on Sunday, but he is coming once in 3 days. That means that after Sunday, he will not come on Monday and Tuesday. Let's say he is coming on Wednesday. Then Thursday, Friday he is not coming. Then he is coming on Saturday. Then again, from here, again 2 days. That is Sunday, Monday is not coming. He is coming on Tuesday. Right, so on. Now, if I ask you, since they have met together on Sunday, when will they meet together? Now, I will be knowing that he is coming once in 2 days. After again, 4th day he will come, 6th day he will come, 8th day he will come. That is nothing but he is coming as per the multiplication table of 2. Similarly, he is coming on the other person is coming on the multiplication table of 3. So that means that for every 3 days he is coming. Next 6th day he will come. Next basically 9th day he will come. So he is nothing but it is basically he is following the multiplication table of himself. Now when I want when do they meet for the next time apart from Sunday that they have met, when they are going to meet next time. That means that if they want to meet, the multiplication table should have multiple of 2 also, multiple of 3 also. And since we are asking for the immediate meet, that should be the least common multiple between them. That is 6. So today is Sunday. If I add 6 days to it, it will be another Saturday. So on Saturday, both of them are going to meet. Right. So that is how you are going to think about it. Right. So that is basically, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So that is 6th day. That will be from the Sunday. Again, they are going to meet. Again, after that, again 6 more days. That is how the things will go. Right. So that is what we have understood to the least common multiple. Now, how to find this? Because we cannot keep on writing the multiplication table and see what is common. Now, what is the method that we are supposed to follow? I will not go for the bookish method where we will take the prime factors and do. Rather, we do 2 simple methods. One method is basically whenever multiple numbers are given, 2 numbers, 3 numbers, how many numbers are given, all I will think is, first we will understand for 2 numbers. For example, if they have given 2 and 3, right? So, what is the common multiple or the least common multiple is nothing but I will take if 2 numbers are co-prime, then its product will be the number that will be divisible by 2 also, 3 also. So, I can directly say 6 is the common multiple. Similarly, if somebody has given you 3 and 4, what is the LCM? So, since 3 and 4 are co-prime, their product itself is basically that is 12 itself will be the least common multiple. That means that 12 is available in the multiplication table of 3 also. Similarly, 12 is available in the multiplication table of 4 also. Right. So, let's say if there are a number, let's say they are not basically, co-primes. That means that let's say if somebody has given you, let's say 6 and 9. Okay. Now, what is the way that I can do? Because I know that if I can bring it to the 2 co-primes, then anyways the product of the 2 co-primes will be its multiple. So that means that when I have 6 and 2, all I see is which is the common number that divides both 6 and 2. That means that here 3 is common. I take 3 out. So this will become 2. 3 2s are 6. This will become 3. Now 2 and 3 are co-prime. So if 2 and 3 are co-prime, what will be its LCM? So LCM will be product of this number, that is 6. And since 3 is also common for both, I multiply this 3 into 6. So 18 will be the LCM of 6 and 9. That means that 18 is available in the multiplication table of 6 also. And also 18 is available in the multiplication table of 9 also. Next number will be multiples of 19, that is 36. Next common will be 54. Like that, for every 18, they will have a common multiple. So this is one thing that you are supposed to understand. Now at the same time, let's say if somebody gives you 10 and 12, right? So what I can do, I know that 2 is common, so that means that this will be 5, this will be 6. So now 5 and 6, 2 consecutive numbers are always co-prime. That means that 5 and 6 is co-prime. So that means that the LCM of 5 and 6 is 30 and 2 is anyways common to both of them. So 30 into 2 will be 60 will be its LCM. Right. So when you are having 2 numbers, you can take the LCM. Now if there are 3 numbers, you can take the LCM of 2. With that LCM, you can start doing with the third number. Right. That is one way to look into it. Now if there are multiple numbers, right. Let's say we'll take 3, 4 and 6. Okay. Now I want to find the LCM of these three numbers. Right, now there are two ways to do it. Right, one, I can consider 3 and 4 are co-prime, so directly find 3 and 4. That means that if they are co-prime, LCM of 3 and 4 is basically nothing but product of them, that is 12. Another number is left as it is, so I will continue with 12 and 6 now. Between 12 and 6, what is common? 6 is common. This is 2, this is 1. So between 1 and 2, again the product, that is 2, will be their LCM into 6. So 12 will be their LCM. So that means that if you look at 12, it is there in the multiplication of 6 also. If you see the 12, it is also there in the multiplication table of 4 also. If you see 12, it is also there in the multiplication table of 3 also. So that means that I am taking any two number where I can form the co-prime and find the LCM. With that final LCM, I will take the another number and do the calculation. But if there are multiple numbers, 5, 6, 7 numbers, then it is not a good strategy to go with it. For a smaller number, you can use this. Right? This will be very helpful when you are having a smaller numbers. Right? That means the number of numbers smaller in the sense that they are actually having only two numbers or three numbers, right? For example, if they are having 20 and 24. So I know that 4 5s are 24, 4 6 are 24, take 4 out. This will be 5 and 6. Since 5 and 6 are co-prime, this is 30 will be the LCM because the product of two numbers. Anyways, 4 was common to both of them. So I can say that 120 is the LCM. Right, so that is even if the numbers are larger, right? So for example, if I want for 75 and let's say 90, right? So now that means that 15 5s are 75, 15 6 are 90. So once you are good in the multiplication tables, right? So 5 into 6, you know that they are co-prime. 30 will be their LCM and 15 was common to both of them, multiply with it. So 450 will be the LCM of 75 and 90. Right, this is one way to look into it. If there are number or total numbers that is given is more, for example, if they have given 3 also, 4 also, 6 also, right, 8 also, 12 also, right. So now there are 5 numbers. I cannot do that first 2 numbers, then again do with the third number. So that will be a little lengthy in that sense. So then what I can do? Then what I can do, always see that what is the largest number among the given number. Now 12 is the largest number. Now check whether 12 is divisible by 2. Yes. 12 is divisible by 3. Yes. 12 is divisible by 4. Yes. 12 is divisible by 6. Yes. Does 12 divisible by 8? No. So that means that when 12 is not divisible by 8, 12 cannot be your LCM. You take the multiple of 12. So the next multiple of 12 will be 12 2s are 24. Right? That means that it will be divisible by 2 also, 3 also, 4 also, 6 also, 8 3s are 24 and 12 2s are 24. That means that 24 is the LCM. Right? So all you can do is take the largest number, and once you know that the largest number, take the multiples of the largest number and keep checking which number will divide them properly. That means that let's say if I am having one more example and we will finish it. Right? Say we are having 3, 5, 8, 12, 15, let's say 20, right? Now this is the number. So what I will do, I know that 20, it will not be divisible by 3, so 20 cannot be LCM. The largest among the given number is 20. I start taking the multiples of 20. 20 2s are 40, again it will not be divisible by 3, so take 60, right? Now if it is 60, it will be divisible by 3, yes. It will be divisible by 5, yes. It will be divisible by 12, 12 5s are 60, yes. It will be divisible by 15, yes. It will be 23s are 60, it will be divisible, but it is not divisible by 8, right? So that means that now I will continue the process, okay? So 60, then again, it should be multiple of 3, that means that, next number that is possible would be 120, right? Because now 60 is divisible by 3. Now if I take 80, again, it will not be divisible by 3. So I will take now, I know that 60 will divide 20 also, 15 also, 12 also, 5 also, 3 also. Start continuing with 60 multiple now. So that already 4 numbers are there, I am searching for only another number. So that is 60 2s are 120. 120 will be divisible by 3 also, 5 also, 15 8s are 120. 12 10s are 120, 15 8s are 120, 26 are 120. So 120 will be your LCM. Right. So that is your standard method that you can see the largest number and start taking the multiples and see which number will completely divide or which multiple of the largest number will be divisible by all the given numbers. That will be your LCM. All right. Okay. Now that is easy to understand. Right. Now I'll not go with the, the primary factor or prime factor method, because, that is more of a lengthy and, that is not really useful, right? So anyways, now we'll go to the concept and try to understand what are the type of question that can appear. It is not that, they will tell you to find in the examination, they will not tell you to find what is the LCM. Now they can give you a statement based question. For example, what is the least number that will be divisible by 2, 3 and 5? This is the first question. That is, it should be divisible by 2 also, it should be divisible by 3 also, it should be divisible by 5 also. When a number is divisible by 2, 3, 5, that means that, if it wants to be divisible, it should be there in the multiplication of 2. It should be there in the multiplication table of 3, it should be there in the multiplication table of 5, because all our multiples will be divisible, right? So that means that now they are asking you what is the least number. So that means that what is my job? Find the LCM. That is the common multiple which is there in the multiplication table of 2, 3, 5 also, right? So that means that what is 2, 3, 5 ka multiplication table? 2 method. If there are small, only 2, 3 numbers, then I go with basically the basic rule of, the co-prime. That is, I'm having any 2 numbers, that is 2 and 3, which are co-prime. So this will become 6 will be the LCM of 2 and 3. Now 5 is left. Now I have to find the process or the, multiplication table or, the LCM between 6 and 5. Since 6 and 5 is also co-prime. So what will be the LCM? The product of it, that is 30. So 30 will be LCM of 2, 3, 5. So 30 is the least number which will be divisible by 2 also, 3 also, 5 also. Now if I ask you a next question, which is the next number? Okay, so the second least number, for example, which will be divisible by 2 also, 3 also, 5 also. So that means that if it wants to be divisible by 2, 3, 5, it should have 30. So that means that the next number will be multiple of 30, that is 60. Third least number will be 90. So for every 30, 30, I will start getting that multiple of 2 also, 3 also, 5 also. Right. So once you understand what is the least, then all its multiples, the LCM multiples, will be the next number that will be divisible by the given number. So this is first type of question. Now what is the kind of question they can ask you? Again, a little addition, 2, 3, 5, same question. They are telling which is the least number that will be divisible by 2, 3, 5, but which should be a 3-digit number. Right. Now the question is not about what is the least or what is the LCM. They are asking, the common multiple of 2, 3, 5, which should be 3-digit. Now I know that the least number was how much? 30. Right, so that will be divisible by 2, 3, 5. Now see the multiple, next number will be 60, next number will be 90, next number will be 120. Right, so all these, for every 30, the same thing will happen. So the 120 is the least number, which is 3-digit in nature, and it will be divisible by 2, 3, 5. Right, so how do you do it basically? You take the least digit, 3-digit number, that is 100. Now divide by the least common multiple, that is 30. So if I divide by 30, so now what it is saying? It will leave the remainder 10. So leave the remainder 10 means what? It means that, if it was 10 less, then it would have been completely divided, since 100 is 10 more than the, the multiple of 90. So that means that, if it was 90, it could have completely divided. So if it is 100, it is giving 10 extra. Now I want to be divisible by 30, that is, I have already 10 extra. How much extra I need so that it can become again multiple of 30? So already 10 remainder you are having, add 20 to it. So 10 plus 20, it will become 30. So if I add 20 to it, already 10 remainder was there. So if I add that 20, so now it has become 30. So now it will be completely divisible. So all you have to take is the least digit number, then divide it by LCM. Whatever the remainder, see, you will understand that much extra you are having, and add how much more needed so that it can become multiple of this. So that means that, if I know that 10 is the LCM, then I know that, I need 20 more to make it, a multiple of 30. So add 20 to it. So 100 plus 20 will be 120. So you don't need to take 30, 60, 90, 120, but you start with this. Now if they are asking the same question, what is the least 4-digit number? Right. Now what I will do, I will again take the same thing, 1000 by 30. Right, if I take 1000 by 30, right, 30 will be 990 will be completely divisible, right? So that means that the remainder will be 10. So that means that if you give 1000, if I divide it by 30, if it was 990, it would have been completely divided. Since it is 1000, I am having extra 10. So I need extra 30, right, so that it can be completely divisible. So for this, add 20. So that is for 20. So the 1020 is the least 4-digit number which will be divisible by 2 also, 3 also, 5 also. So this is first type of problem. Okay. So that is when given number, what is the least number that will be divisible by x, y, z is the thing, but LCM of x, y and z. Okay. So that is one thing. Now if they are asking 3 digit, then you have to see or 4 digit, whatever the question, as per the question you have to understand. Once it is LCM, the multiples of LCM it will be, you will be keep getting that common multiples, right? So that is one thing that you have to. Now the second type of question, what is the least number when divided by 2, 3, 5 leaves a remainder 1 in each case? Whenever you are dividing by 2, you are getting 1 as the remainder. Whenever you are dividing by 3, then also you are getting 1 remainder. Whenever you are getting 5, then also you are getting 1 as the remainder. Now the question is simple, right? So what is that least number which leaves remainder 1 when you divide by 2 also, 3 also, 5 also? First, how do you think about it? I don't think about that number which leaves the remainder. First, I will think which is the number that is completely divisible from 2, 3, 5. So which number will be completely divisible by 2, 3, 5? So it is nothing but LCM. So that means that 30 will be completely divisible by 2 also, 3 also, 5 also. Now the question is saying there should be one remainder. So that means that if 30 should have been there, it would have been completely divided. Since I want one remainder, I will add 1 to each case. So that means that if I add 1 to 30, so 31 will leave remainder 1 when you divide by 2 also, when you divide by 3 also, when you divide by 5 also. Similarly, if the question was what is the 3-digit number, least 3-digit number, which when divide by 2, 3, 5 leaves remainder 1. Again, first what is your thought process? Which number is the least number that will be divisible? That you have to think. That means that 30 is LCM. They are asking for 3-digit. The least 3-digit number is 100. I divide it by 30. When I divide it by 30, I will remain with remainder 10. So that means that 90 would have been completely divided. 10 has extra. Now if I want to make it a multiple of 30, for this 10, extra 20 need to be added, so that total can become 30 extra. Right, so that means that add 20 to it. So the 120 will be completely divisible by 235. But question is not about which number divides by completely divisible by 235. In each case, it has to leave the remainder 1. So that means that if 120 is remainder, not leaving any remainder, what will be the number that will leave the remainder 1? Add 1 to that. So add extra 1 to it. So 121 is the least 3-digit number. When you divide by 235, leaves the remainder 1. Okay, this is another type of question that you are going to get. Right? Alright. Now, looking at it, the third type of question, which is very interesting. Okay. Right? So that means that, let's say, if the number is something like this, when you divide by, let's say, I will tell a number, 4, 5, let's say, we'll take 3, 4, 5. When I am dividing a number by 3, 4, 5, okay, what is the remainder that I am getting? Okay, so that you are supposed to asking. So there is a question saying that when you divide a number by 3, 4, 5, it is not leaving the same remainder. If the same remainder, I would have found the LCM, add that extra remainder, you would get the number. Right, now the question will be other way around. What is the question? When you divide by 2, for example, when you divide by 3, it is leaving 2 remainder. Okay. Now similarly, when you divide by, let's say, 4, okay, so it is giving 1 remainder. Okay. Similarly, sorry, my number na illi slide in the vapas mado, cut. Okay. Third type of question anna tanka admele vapas mado. Okay. Now there is a third type of question. What is this third type of question? Right. So let's understand with the smaller number so that you understand it better. Okay. Now let's say something like this. Let's say I'll take just 2 numbers now. Let's say 4, 5 and 6. Okay. Now 5 and 6. Now there is a number when you divide by 5 and 6. Let's say it is leaving, first case is leaving 4 as the remainder. Next case it is giving 5 as the remainder. Okay. So that means that in first case remainder is 4. In second case when you divide by 6, remainder will be 5. What is the least number that is possible? Now it is not a common remainder and remainders are different here. So what I have to do here? Now comes the concept of the negative remainder. So what all I have to do is take the LCM of the given number, right? So what is the LCM? 30, right? Now see the difference between the given number and the remainder. What is the difference? 1. What is the difference between 6 minus 5? 1. So that means that this is only possible to find when the difference between the given number and the remainder is same. In both the cases, difference between the number and the remainder is 1. So that means that you subtract that 1. So that means that 29 is your answer, right? So that means that when you divide 5 by 29, right, 5 5s are 25, 4 will be the remainder. Similarly, if you divide 29 by 6, 6 4s are 24, 5 will be the remainder. So that means that if there are two numbers x, y, z and it is leaving a, b, c as the remainder, and given that x minus a is equal to, that is the difference between the number and the remainder are same, is equal to y minus b, that is number and remainder, which is equal to z minus c, right? So this is the difference. In all the case, difference is same, that is x minus a, y minus b, z minus c. So what you have to do, find the LCM of x, y, z and then subtract this difference. In this case, the difference is 1, subtract that difference. What is the difference that you are subtract? That is number and the remainder. So it has to be same for all the cases, right? So that is your third type of question that you can expect. All right. So the three types: one which is divisible by x, y, z, LCM. Smallest number x, y, z, leave common remainder r in each case, then you find the LCM, add the r. If it is divided by x, y, z but remainders are different, that is a, b, c, but what is the condition that should be there? X minus a, that is the number minus remainder, second minus is the second remainder, third number minus third remainder. If they remain same, then only you can find it out. How you will find it out? You will find the LCM, then take that difference, that is x minus 5 or y minus b or z minus c, whatever the difference that I have put at k here. So that will be your answer. All right. So next is basically your HCF. Okay. So now before finding HCF, we will solve few questions which is based on the LCM, and then we will come back to HCF that has been asked in the previous year examination. Right. Now there are three traffic signals. Each signal changes the color from green to red. Okay. So first 1, 2, 3. There are three traffic signals. One is changing at 25 seconds. So it is taking 25 seconds. After 25 seconds, again it will take red to green. So for each 25 seconds, it is changing from one color to other. Next, second one is taking 39 seconds. And the third one is taking 60 seconds. Now, the duration of green and red colors are same. That means that green to red also or red to green also, it is taking same time. If it is taking green to red 25 seconds, then red to green also it will take 25 seconds. Now at 2 p.m., they together turn green. That means that at 2 p.m., what is happening? All are green. Now at what time they change to the green next simultaneously? Already it is green. So that means that first time it has to change to red. From red again it has to change to green. So not the least common multiple, but twice the least common multiple that you are supposed to find out. Right? So if you think logically, what is that? Three things has been given: 25, 39, and then 60 seconds. What is the LCM of these three? Right? So now let's say if I take 25 and 39, right? Is there any common multiple? No. Or let's say if I take 25 and 60, right? Then I will take 39. So wherever common I can get, I will get the common. Right? So now that means that 25, 35, the 5 is common. So I can take, this is 5, this is 12. Okay. Now 12 and 5 are co-prime. So that means that this will be 60. Right? Because when their two numbers are co-prime, their product will be their LCM, and 5 was anyways common to both of them. So that means that 25 and 60, the LCM was 300. Now I have to continue my process with another number 39. Now what I can do within 300 and 39, what is common? 3 is common. 39 is 3 13s are 39. So if I take 3 out, this will be 100. This will be 13. Now, what is the rule that you know? If one number is prime and other number is not a product of this prime number, then that means that they are co-prime. So that means that 113 are co-prime. They do not share any common factor apart from 1. So that means that what will be LCM of 113? That is nothing but the product of those two numbers. That will be 1300, and 3 was anyways common to both. So that means that 3900 is the LCM. 3900 seconds. That means that they chain together once in 3900 seconds. So now they are not asking for green to red, but rather than green to green. So that means that 3900, again 3900, right? So now that will be basically 7800 seconds. So what is 7800 seconds? 3600 seconds is 1 hour. 7200 seconds is 2 hours plus 600 seconds. Each 60 seconds is 1 minute. So that means that 600 seconds means 10 minutes. So 2 hours 10 minutes. What is 2 hours 10 minutes? 4:10 p.m. That will be your answer. Right. So here you have to understand the logic. Right. So that means that when you know that 3900 seconds. Okay. Now 3900 seconds is the LCM. That means that 3900 seconds may how much the first signal would have been chained. 25 for for 100 seconds 4 times. So 4 into 39. Right. So it is in the even number. So even number means basically it is changing into red to green, and again it is coming green. So that means that at 3900 seconds, first light which is changing at 25 seconds will be at the green only. Now if you look at the second light which is taking 39 seconds. If it is taking 39 seconds, how many times it would have changed in 3900 seconds? 100 times. 100 times is again a even number. For each even it is again turning back to red. For each odd it is turning to red. For each even it is turning to green. Right. So that means that again this will also be green. However, if you look at this and if I divide 60, right, so then you will be not getting this, right? So that means that at that point of time you have to understand that it is not changing to red again. So that means that so if I want to take it 2 times, that is green again commonly for both of them, then I have to take that twice the LCM. So 7800. So 7800 means 410 will be your answer. Next. Okay. Next concept we will discuss about HCF. Okay. Now HCF again, simple highest common factor. In some books it has also written greatest common divisor. Okay, that is GCD, right? So now if you look at what is the word here, factor is there. What is the meaning of factor? Any number that divides the given number, right? So that is called its factor. So that means that if 6 is there, what are the factors? Which number divides 6? All are there its factor. That means that 1 is its factor, 6 is its factor, 2 is its factor, 3 is its factor. So all those numbers which divides the given number are the factors of a given number, right? So similarly, if there are 2 numbers are there, 6 and let's say 4, that means that 1, 4, 2. So that means that these are the factors of 4. That means that 4 will be divisible by 1, 4 will be divisible by 4 also, 4 will be divisible by 2 also. So these are the factors of 4. Now, what are the common factor? 1 is common, 1 is common, 2 is common, 2 is common. Here you are having 4, here you do not have 4, here you have 3 and 6, here you do not have 3 and 6. So common factors are 1 and 2. When it is common factor is 1 and 2, we are not searching for the least one here, highest one. What is the highest one? 2 in this case, right? So that means that whenever 2 numbers are given, and if you look at another number, let's say 3, what is the factors of 3? 3 is a prime number, it will be divisible by 1, and the number itself, that is 3. So if you look at here, all the number will be divisible by 1. So that means that 1 is the common factor for all the integers. So that means that if there are no other common factors also, then there will be 1 which is common. So that means that if 2 numbers are co-prime, we don't have any common factor apart from 1, then what will be the HCF of those 2 numbers? 1 will be the HCF, right? So now how to find it out? right? Now again, 2 method, right? So the common factor method, within that we will have one co-prime method, one the difference method, the regular method that you can see anywhere, right? Taking the factor, seeing the common factor. So that is more lengthy kind of problem, which we preferably not do in an exam where you are running against the time, right? So that means that if I want to have 4 and 6, what I will do, I'll take 2 common, then that means that 2 2s are 2 3s are. Now 2 and 3 are co-prime. If they are co-prime, they do not have any common factor apart from 1. That means that common factor between 2 and 3 is 1, and 2 was anyways common factor. So that is 2 will be your HCF, right? So that means that similarly, if I am having 10 and let's say 12, right? So that means that I will take 2 out, 2 5s are, 2 6s are. Now 5 and 6 are co-prime. That means that it will leave, have 1 as the common factor. Now 2 is the anyways common to both of 10 and 12. So that means that 2 into 1, 2 will be your HCF. Right? This is one method. So that is finding the common factor, larger number, for example, 25 and 45. Right? So now I know that initially you don't need to find out directly co-prime. Try to have that understanding that 5 is common. If 5 is common, this will become 5 5s are, 5 9s are. Now between 5 and 9, there are no prime number, because both are, one is a prime number, other is not the multiple of the prime number. So that means that 5 and 9 are co-prime. If two numbers are co-prime, what will be the common factor between them? Only 1. So anyways 5 was common, so 5 into 1. So that will be 5 will be HCF of 25 and 45. Right. Similarly, if I want a larger number, let's say 30 and 55. Right. So what I can do, again take 5 common. So 5 6 are, 5 11s are. Now 6 and 11 are co-prime. That means that they have only one common factor, that is 1. Along with that 5 was common to both. 5 is the HCF of 30 and 55. Right, this is one way to look into it. Other is what? If the more numbers are given. Right, if the more numbers are given, for example, let's say if I have 30, if I have 35, I have 40, right? Let's say I have 50. Okay. So whenever these kind of numbers are given, so what you have to find? Right. Now, whenever I am finding the HCF for these numbers, what I will do, I'll take any two numbers, for example. Take the largest two number, that is 50 and 40. Right. What does that mean? The difference is how much? 10. That means that you start checking whether the given number will be divisible by 10 or not. So that means that 30 will be divisible by 10? Yes. Is 35 divisible by 10? No. So that means that 10 cannot be your HCF. Now find out the factors of 10. What are the other factors of 10? One is 1, 10, 5, 2. So next highest factor of 10 is 5. So check with 5 directly. So it is divisible by 5. This is also divisible by 5. This is also divisible by 5. This is also divisible by 5. So that means that 5 is your HCF. Right? So that means that it is a very simple way to do it. Try to understand with 2-3 problems so that you understand it better. Right? Now, for example, again, you have 30, 45, 55, right? Let's say 65. So what I will do, I will see what is the highest difference between, two closer numbers. Right? So here you have difference of 10. Right? You are here having also difference 10. Right? If you are here having difference is 15. Right? So the highest difference is 15. When you are having arrange the number, basically, when you arrange the number in a, order, right? See what is the highest difference that you are getting between any two consecutive number that you are having here. So the 15 is the highest difference. Check whether 30 will be divisible by 15. Yes. 45 will be divisible by 15. Yes. But does 55? No. Right? So that means that next you can check with the factors of 15. What is factor of 15? 15, 1, 5, 3 are. Next highest factor of 15 is 5. Check with 5. All numbers will be divisible. So I can say that 5 is the common factor. So this is the best way to do when the numbers are larger. Take the difference between them, any two number. Find out that, the difference, whether it is divisible by the difference. If it is divisible, all the numbers are divisible by the difference, that the difference itself is HCF. If they are not divisible by difference, then what you are supposed to do, start taking the highest factors of the difference and start checking with those factors. Whichever number will help you to divide that will be your answer, right? Now again, what are the various questions, right? So now, as I told you, one thing you have to remember is HCF cannot be greater than difference of two numbers. The maximum HCF can be difference between the two numbers. That is the maximum, the HCF you can have, right? For example, if I have 2 and 4, what will be HCF? 2 will be the HCF. That is, the difference between 4 and 2 is 2. So HCF can be at max the difference. So it cannot be more than the difference. This you have to understand, right? Now, what are the various types of question? First question, they have given you the number. What is the largest number which divides x, y, z exactly, right? So that means that which number will divide the three numbers exactly. If it wants to be divide all the three numbers, it has to be a factor of those numbers. So that means that if I ask you 10, then 15, then let's say 20, right? So what is the number that will divide 10 also, 15 also, 20 also without leaving any remainder? That means that without leaving remainder means it has to be completely divisible. So what I do, I take the difference of these two numbers, right? The difference is 5. I check with 5 whether 10 is divisible by 5, yes. Whether 15 is divisible by 5, yes. Whether 20 is divisible by 5, yes. So that means that HCF is 5, right? So that is first type of question that you can expect. Second, what is the largest number which divides x, y, z and remainder are in each case? So what is the meaning of it, right? So let's say if I take this 17, 22 and let's take 20, 32. Now the question is saying like this: when you divide a given numbers, that is 17, 22 and 32, in each case you are getting 2 as the remainder. It is not completely being divided, but you are getting 2 as the remainder. Now what is the meaning of it? If 2 is the remainder, that means that when you divide 17, you are getting 2 remainder. What is the meaning of it? 15 was completely divisible. 17 is 2 extra than the completely divisible by number. Similarly, if 22 is giving 2 remainder, that means that 20 was completely divisible. 2 is the remainder. 32 is completely divisible means, leaving 2 remainder means 30 was completely divisible. 2 is the remainder. So that means that you can have, okay, I can say that 15 will be completely divisible by a given number. 20 will be given by completely given number, and similarly 30 will be completely divisible by given number. So that means that if the question is asking which number will divide 15 also, 20 also, 30 also, it just becomes the first type of problem. That means that you are finding the HCF of 15, 20, 30. So where I see the difference here 5, here it is 10. So that means that the least difference is 5. So you can start with 5. So 5 will divide 15, yes. 5 will divide 20, yes. 5 will divide 30, yes. So 5 will be your answer. So when you divide 5 and 17 by 5, 15 3s are 15, 2 will be the remainder. 15 4s are 20, then 2 will be the remainder. Similarly, 15 6s are 30, 2 will be the remainder. So answer will be 5. So what we are going to do, whatever the number that they are giving, we will deduct the remainder that is extra. So that when you remove that extra, then I will come to know that numbers will be completely divisible. Then I find the normal HCF. That is HCF of x minus r, y minus r, z minus r. That means that if I take that remainder extra, the remaining number will be divisible. Then I take the HCF of those numbers. That is type number 1, right? What is the type number 2 within the same? For example, let's take like this. If a number is 23, then let's say 38, then let's say 53, something like this. Now they are telling that when you divide the 3 given number by a certain number, what is the largest number which will leave the same remainder. Now they are not telling what is that remainder. If they would have told the remainder, then you would have removed that remainder so that you will know which number will be completely divisible, then you take the HCF. In this case, what they are doing, they are not telling you what is the remainder. Then what you are supposed to do, take all the differences. What is the difference between 38 and 23? What is the difference? 15 is the difference. What is the difference between these two numbers? Again 15 is the difference. So that means that when you are having 2, 15, 15, HCF of 15 is 15. So if you divide 15 by 23, 15 ones are 15, 8 will be remainder. If you divide 38 by 15, 15 twos are 30, 8 will be the remainder. Similarly, if you divide 53 by 15, 15 threes are 45, 8 will be the remainder. So that means that when you divide by 15, always you are going to get the 8 as the remainder. So what I have done, since I was not knowing what was the difference, if I know the what of the difference, then I would have subtracted 23 minus 8, I can make it 15. Then I can subtract 38 minus 8, I can make it 30. 53 minus 8, I can make it 45. Then I can find the HCF of these two. Now since they were not told what is that, the common remainder, what I will do, I'll just take the difference of the given numbers and find the HCF of those differences. So that means that we'll have one more problem for your better clarity. Right? Let's say there is 20, let's say there is 36, let's say there is something called 84. Now they are telling that there is a number which divides 26, 36, 84, leaves the same remainder in each case. Which is that largest number possible? That is the question. Now what I will do, I will take the difference between these two, 16. What is the difference between these two? Right, 84 minus 36. How much will be the difference? 48 will be the difference. Right, so this is 16, this is 48. So this is the difference. Now what I will do, I will take the HCF of these two numbers. What is the HCF of 16 and 48? Right, so 16 is common. 16 ones are 16 threes are. Since 3 and 1 will give you 1 as the common factor into 16. So 16 will be your HCF. Right, so that means that if you divide 16, 20 by 16, 16 ones are 16, 4 is the remainder. 16 twos are 32, 4 is the remainder. 16 fives are 80, 4 is the remainder. So all you have to take is the difference between the given numbers and then find the HCF of the given numbers. So that is your third type of problem. Right. So that finally we are having largest number which divides XYZ and leaves the remainder A, B, C respectively. Right. Now the third type of problem, here you are having the different reminders. The different numbers are giving different reminders. So what is the meaning of it? Let's say, there is a number, okay. Right, let's take any number, okay. Let's take 3 numbers, 30, 45, okay. And ಇಲ್ಲಿಂದ ತಗೋ ಇವಾಗ ಹೇಳ್ತಾ ಇರೋದ್ರಿಂದ ಡಿಫ್ರೆಂಟ್ ರಿಮೈಂಡರ್ಸ್ ಅಂದರೆ ಯಾವುದಪ್ಪ? Okay, all right. So let's take another kind of problem. So let's say here what will happen, let's say if they have given a number, okay, 3 numbers, 2 numbers I'll take it for you, right? Let's say 12, okay, and let's take 18, okay, take 3 numbers, no problem, take 24. Let's say there are 3 numbers. Now a question is saying that when you divide by a certain number, when you are dividing 12, these are the numbers, okay, it is leaving the remainder as 2, this is leaving the remainder as 3, this is leaving the remainder as 4. So that means that here, the difference reminders are coming. If it was the same remainder, then it would have been easy, right? Because I can subtract that remainder, then I will be knowing that number will be divisible. Now the same logic applies here. Now if they are telling that 2 is the remainder, right? So, that means that 10 should be completely divisible. If 18 is leaving 3 as remainder, that means that 15 will be completely divisible. Similarly, when I 24 by 4, 4 is the remainder, that should be 20 is divisible. That means that which number will divide 10, 15 and 20 completely? It will translate something like that. So the answer will be, the 5. When you divide by 10, it will be divisible. 15, 20. So when you divide 12 by 5, you give 2 as the remainder. When 5 by 18, 5 3s are 15, 3 will be the remainder, 5 4s are 20, 4 will be the remainder. So this is basically the other method. So that means that when the largest number which divides x, y, z and leaves remainder a, b, c, that is different remainder, then answer will be HCF of x minus a, because once you subtract that extra remainder, number should be divisible. Similarly, from y, if you subtract b, number will be divisible, z minus c. So this is your answer. All right. So that once you find out, you will get the answer. Now, where exactly the HCF will come, since you know that it is divisible. Let's say, I want to measure 30, 40, 50. There is a room with the dimension now 30 meter, 40 meter and 50 meter. I want to get the tape so that I can measure them exactly. Now, what is the length of the tape that I should get? If I get 1 meter tape also, I can measure, because I can measure this 30 meter 30 times. Similarly, 40 meter 40 times, 50 meter 50 times. If I get 2 meter tape, then also I can measure 30 meter 15 times, 2 meter 2 meter, like that. Like that, 40 meter 20 times, 50 meter 25 times. So that means that smaller, that means that, let's say if I taking 1 meter, that means the 30 meter has to be measured how many times? 30 times. 40 meter has to be measured 40 times. 50 meter has to be measured 50 times. If I take 2 meter, then what I can do? I have to measure this 15 times. Right? 30 meter 2 15 times. Similarly, 40 meter has to be measured 20 times. And then 50 meter has to be measured 25 times. So here if you look at 30 plus 40, 70, 120 times I have to measure. You can understand the amount of work that is going through here. Similarly, 15 plus 20, 35, 35 plus 25, that is 60 times I have to measure. Now let's say if I take another common factor, 5 meter. So that means that 30 meter has to be measured 6 times, 5, 6 times, 48 times. Similarly, 5 meter, if I want to measure 50 meter, then it will take 10 times. So total 6 plus 8, 14, 14 plus 10, 24 times I have to measure. Right. Now, if I take 10 meter, then I have to measure only 3 times, 40 meter 4 times, then 50 meter 5 times. Right. So that is 3 plus 4, 7, 7 plus 5, 12. So I just need to divide 12 times. So the larger number, which given the divide number, my job will be less. So if I want to take if I want to go to shop and ask what is the tape size that I need, then I will tell which has to be divided exactly. That is one thing. That means that it has to be factor of all the 3 number. Among there are different number that can divide exactly. I want the largest number that divides, so that I can measure less number of times. So I will get the HCF of 30, 40, 50, that is 10 meter. Once I get 10 meter, I can measure the least number of times. So sometimes they can ask you how many times you can measure. If you get the largest tape, how many times? Then you should know that this is 3 times, this is 4 times, this is 5 times, total 12 times I am going to measure. So within the 12 attempts, I can completely measure the room. All right. So this is one. Now last one, that is HCM and LCM of fractions. Okay. Now let's say I want to take HCF of 1 by 2 and 1 by 4. Right. Similarly, I want to take LCM of 1 by 2 and 1 by 4. Right. So how do I do it? So the HCF of fraction is nothing but whichever you are finding, whether HCF or LCM, whatever that you are finding. If you are finding HCF, you have to find HCF of numerator divided by LCM of denominator. Similarly, if I want LCM, then again LCM of numerator and HCF of denominator. Right. So that means that first one, 1 by 2, 1 by 4. What is the numerator in both the cases? 1, 1. So HCF of 1 is 1. What is the LCM of 2 and 4? LCM of 2 and 4 will be 4. Right. So that means that HCF of will be 154. Similarly, if I want to find LCM, then LCM of numerator, that is 1 and 1, LCM will be 1. What is the HCF of 2 and 4? HCF is 2. That is 2 will divide both 2 also, 4 also. So 2 will be the HCF. So that is LCM will be LCM of numerator divided by HCF of denominator. Similarly, HCF is HCF of numerator and LCM of the denominator. This formula you should be knowing. And finally, the one rule that applies only for two numbers. What is that rule? If there are two numbers, let's say 10 and 15, right? So what is its HCF? That is a number that, what is the HCF means? The factor that divides both 10 and 5. Largest number will be 5, right? What is the LCM? LCM, that means that it should be multiple of 10 also, 15 also. How do you find it? 1, you can take the common factor out, then convert them into co-primes and then see. So that means that if I take 5 out, this will be 2, this will be 3. Now 2 into 3 is a co-prime, so LCM of 2 into 3 is 6. That is product into 5. So 30 will be your LCM. That is one method, or you can take the larger number and then see the multiple. 15 will not be divisible by 10. Take the next multiple of 15, that is 30. 15 2s are 30. See that 30 is divisible by 15 also, 10 also, 30 will be your LCM. So that means that this is HCF and 30 will be your LCM. Now if you look at here, the numbers product, that is 10 into 15, this is also 150. The product of LCM and HCF, that is 30 into 5, this is also 150. That is, the product of two given numbers will be equal to the product of its LCM and HCF. So that is basically a rule. That is when it is applied only for two numbers, not for more than two numbers. Whenever two numbers are given, the product of the two numbers is equal to LCM and the product of LCM and HCF of the numbers. Okay, all right. Now we will solve few problems and then we will end up. Now first type, what is the smallest number greater than 1000 when divided by any one of the number 6, 9, 12, 15, 18, leaves the remainder 3. When you are dividing by 6 also, 9 also, 12 also, 15 also, 18 also, you are getting the remainder of 3, right? So now if I take the LCM of them, if you are finding for 18, then you don't need to add 6 because already 18 contains 6 within it. Similarly, 18 contains 9 within it, right? So all I have to find it is 12, 15 and 18. Okay. Now 12 and 15, if I take what is the common? 3 common, this will be 4. 3 4s are 3 5s are. So 4 and 5 are co-prime. So this will be 20 into 3. That is 60 and 18. Now if you want to find 60 and 18, 6 is common. 6 10s are, 6 3s are. So that means that 10 and 3 are co-prime. So that means that LCM will be 10 into 3 and 6 was anyways common. So 30 into 6, 180. So 180 will be your LCM of 6, 9, 12, 15, 18. Right? So if it is 180, next number will be 360. That is all multiples of 180 that will become common multiples. Now how do you do it? You take 1000, you divide it by 180, see what is the remainder. 185s are 900, so that is 18 5s are 90, so 185s will be 900. So if I divide 1000, what will be the remainder? 100 will be remainder. So that is 100 is extra, 900 is divisible. So but I need what? I need basically a number which is completely divisible. So how much extra I need to add? Already 100 extra is there. It should be multiple of 180, so add extra 80. So if you add 80 here, so what will happen? Number will become 1080. So now 1080 is that number which is completely divisible. But question is asking what? It should leave a remainder of 3. So add 3 to it. That means that 1083 will be your number. Right? So that is how you are going to do it. So 1083 will be your number. This is one method. In the exam, always you don't need to do this also. You can go through the option also. What is the option? You know that 3 is the remainder. So if I remove that 3, that means that, if I reduce the 3, remaining number should be completely divisible. So if I reduce 3 here, number would have become 1060. If I reduce 3 here, it would have become 1070. Now this will become 1080, this will become 1180. Now this, when I remove the remainder, that means that remaining number should be divisible. So that means that 1060 should be divisible. Let's say it should be divisible by 9. What is the rule for 9? Divisibility rule we have discussed in the last class. Add all the digit. If it is divisible 9, number will be divisible. So 6 plus 1, 7, not divisible by 9. So this is not divisible by 9. 7 plus 1, 8, not divisible. Similarly, 1 plus 1, 2, 2 plus 8, 10, not divisible by 9. Here 8 plus 1 is 9. So it will be divisible. So this will be your answer. That is using the common sense and doing in the examination. Right? Now 2024 question. They tell that there is a 421 and 427. When divided by the same number, leaves the remainder 1. And you are remindering 421 also, 427 also, by a certain number it is leaving the remainder as 1. Right? Now, how many numbers can be used as the divisor in order to get the same remainder 1? So, how many factors which will give 1 as the remainder? Now, we will think about it. Right? Now, you think about it that there is 421. Since it is leaving the remainder 1, 420 should be completely divisible. And 426, that means that 427 is leaving one remainder. So 426 is completely divisible. Now I have two numbers, 420 and 426. I want to see which are the factors. What is the highest factor possible, that is HCF, is nothing but difference between these two. First take the difference, see the difference will divide both the numbers. If the difference is dividing, then you keep on doing it for other numbers, right? So are its highest factors. So difference is 6, I check with 6, 6 sevens are 42, it will be divisible. Similarly 6 sevens are 42, 6 ones are 6, this will also be divisible. That means that 6 is the number which will divide both 420 and 426. That means that if 421 is there, when you divide by 6, it will leave one remainder. 427 is there, it will leave. So now what is the next factor that will divide 420 is all the factors of 6. What are the factors of 6? 3, 2, 1. Now that means that if you divide by 3, if it is divisible by 6, this it will be divisible by 3 also, it will be divisible by 2 also. So if we divide by 3, 420 will be divisible, 421 will leave one remainder. 426 when you divide by 3, it will be divisible by 427 will leave one remainder. So 3 is also satisfies the condition. Similarly 2, 420 even number completely divisible, 421 odd number one remainder. 426 even number completely divisible, 427 odd number one remainder. So 2 is also satisfies. But you should not consider 1. Because 1 anyways will divide all the numbers completely, right? So 1 will not leave remainder 1. So it will completely divide 421 also 427. So 6, 3, 2. There are 3 such numbers which will leave a remainder when you divide 421 and 427. Now another 2024 question, and remaining I will give you for the homework that you have to do and also try to comment them in the comment section. Alright. Now see here a box, a can X, here it is a can, right? X contains 399 liters of petrol. There is another can Y which contains 532 liters of diesel. They are to be bottled in the bottles of equal size so that whole petrol and diesel would be separately bottled. So that means that you need to have a measure in such a way that both 399 as well as 532 liters has to come in a same quantity of a bottle. So that means that what is the meaning of it. So let's say if I take 3 liter ka bottle, so I can divide 399 to 3 liter, 3 liter, 3 liter, like that 133 bottles I can make of 3 liter. Like that, it has to be completely, nothing has to be left out. So what is the bottle is in the capacity liters of integer. So you cannot have 1.5 liter. So all is basically integer. How many different bottle size are possible? That is how many factors are possible. I can have 1 liter also. 1 liters of 399 bottles, 1 liter of 532, like that I can have. So now what I have to do, since they are asking about HCF and other common factors, not just HCF, all the common factor between 399 and 532, which divides both 390. So what will you do? 399, 532. First job is finding the difference. What is the difference between these two numbers? Difference will be 133, right? Now check with 133 whether 133 will divide both these numbers, right? So 100 3s are 300, 33 3s are 99, so 399 will be divisible. Similarly 100 4s are 400, 33 4s will be 132, so that means that 133 liter bottle can be used. Now remaining what you should do, factors of 133. 133 is what? 133 into 1, 19 into 7. Right, 19 sevens are 133. That is why you should always be very good at the numbers or the multiplication table up to 20. So that if I look at 133, I know that it is 19 sevens. Right. So that means that 133 liter I can use, 1 liter also I can use, 19 liters also I can use, 7 liters also I can use. Right. Is there anything else? No. Only 4. So there are 4 different bottle sizes. 1 liter bottle, 19 liter bottle, 7 liter bottle, 133. So I can use 3 also I can use? No. right? 3 I cannot use, right? So, 133 will not be divisible by 3. So that means that 4 different bottles I can use, right? So that is your answer B. Right, now this is your practice question. Joseph visits the club on every 5th day. Harsh visits on every 24th day, while Sumit visits on every 9th day. If all of them met on a club on Sunday, then which day all of them will meet again? Answer is Monday, Wednesday, Thursday, Sunday. Next. What is the least 4-digit number which divided by 3, 4, 5, 6 leaves the remainder 2 in each case? One, do with the regular method. Second, do with the option. Both you think, so that you will understand. Next, the last one. Sita, Geeta go for the swim after gap of every 2 days and every 3 days respectively. That is Sita coming for every 2 days, Geeta coming after every 3 days. If 1st January both of them went for a swim together, when will they go together next? Right, so first is 1, then from there you have to take the LCM and add it. So whatever the way that you are going to do, understand and do it. These are the 3 problems that you are supposed to solve and put the answer in the comment section. More you participate, I will come to know that whether you are understanding it or not. Right, so from the next video I will be starting with the averages. Here in the next video, as I told you, 2 classes or 2 videos for an entire chapter, so that we can finish them by December. Right, so that is the target. So number system was a little lengthy, so I have taken it more lengthier. So remaining averages, percentages, all these chapters we will do 1 or 2 lengthy classes, to 1.5 hours to 2 hours kind of classes, and we will finish the thing so that you have a broader understanding rather than having multiple short videos. All right, see you. Okay, all right, so then see you with the next video. Thank you for your participation. See you.